Moving right along. One of the things that we're changing this time around in the class is we're going to introduce the idea of testing much, much earlier. And we're going to introduce the tool that we're going to use for a lot of our testing called RSpec. It actually is a descendant of some ideas that come from the Java community. Here's a very smart gentleman who says, debugging is twice as hard as writing code in the first place. Therefore, if you write the code as cleverly as you can, by definition, you're not smart enough to debug your own code. Very smart man. In case people don't recognize him, he is a Turing Award winner. Brian Kernighan is the co-inventor of the C language. You might have heard of it. It's one of the languages named after famous letters of the alphabet. Here's another very smart gentleman who's influential in the history of programming languages. This is Edgar Dijkstra, who won the Turing Award for his work on the importance of structured programming. He's the author of a very famous missive called Go-To Statement Considered Harmful from back in the elder days. And he says that testing can never demonstrate the something of errors in software, only there is something else. Anybody know what the blanks are? Absence and presence. Testing can demonstrate that you've got bugs, but it cannot demonstrate that you are free of bugs. And I think an even more pragmatic version of this, that if any of you have ever visited a Google campus, you may have seen this. Debugging sucks, testing rocks. After 3 years of doing it myself, I could not agree more. So my goal by the end of this class is you will love testing. You will love Big Brother. I mean testing. You will love it so much. You will love it so much that just like you get that little dopamine surge when you get a Facebook message or a text, you will get a little dopamine surge when you see a test go from failing to passing. Believe it. In fact, as recently as 2010, there were surveys done that showed that a big problem with problems in finding major bugs in software didn't have to do with the quality of the code, but it had to do with the problems about the testing process, the way that testing was instituted in the organization. So my other goal is to make sure that when you come out of this class, you have none of these bad habits and that your habits about testing reflect best practices now. Testing is way more fun than it used to be. So what is testing like today? Well, we could start with what it used to be like. Before, some developers would finish the code, they'd throw it over the wall to the QA department, and then the QA staff would sort of manually exercise the software, they would poke at it, and then after a while they would sign off, looks good, then it would ship and there'd be a ton of bugs. Today, it's quite different. First of all, testing is part of every iteration. You're always testing. In fact, you actually would start out thinking, before you write your code, you're thinking already about how could I test this as I write it. So you test your own code, developers test their own code. There's a lot of automation. The idea that testing is manual is almost obsolete. There's extremely few cases where you cannot automate some tests that you would normally have performed manually. And this is a very big insight that saves you a lot of grief. So does that mean that there's no role for a QA group or a testing group? There absolutely is a role, but they don't write tests. That's not what they do. They're like consultants who help you make your code more testable and who improve the tools and the processes company-wide around testing. There's a kind of a famous figure that several years ago was floating around that Microsoft said that for every developer, they had one tester. There was a 1-to-1 ratio between developers and testers. And around last year, I asked some colleagues at Google, what is that ratio at Google? How many testers per developer do you have? And they said, well, it's about for every 10 developers, maybe, we've got one tester. Jaw drops to floor. Google, the home of reliable code that powers hundreds of millions of people's web activities. But it turns out that the testing engineers at Google don't write tests. That's the job of the people who write the code. The testing engineers make the testing environment better. So it's a really different view on division of labor. And the message is that software quality now is not just the result of one specific group saying we're the QA group. It's the process. The process has to involve developers from the very beginning. So the big picture of how we're going to do testing is BDD and TDD, which is behavior-driven design, test-driven development. And they actually are quite parallel to each other. Behavior-driven design says you sit down with the user and you develop stories, and we're going to call those the features you wish you had. It's how you wish the app would work, but you haven't written that code yet. And as we'll see, using a tool called Cucumber, those stories actually become runnable acceptance tests for your app. Remarkable. Now, once you've got a story for the feature you wish you had, the next thing you do is you think about, well, okay, how do I write the code to implement that feature? And the way I do that is I've specified in my user stories the steps that my app has to go through to implement that feature. And for each one of those steps, I'm going to write tests for the code that I wish I had. So I'm going from a feature I wish I had to the code I wish I had. What does this look like? Well, we start out with a Cucumber user story in which the very first step of the story immediately fails because it's asking to exercise functionality that by definition doesn't exist. So as we start to think about that functionality, we think, how are we going to write the code? we start by writing tests for the code before we have the code. Of course, the test fails. It would be really cool if the test passed without having the code there. Our lives would be much easier, but that doesn't happen. So we have to work on creating the code until that test passes. It goes from red to green. And once we've done that, at some point we've implemented enough code that that entire step of the story is now green and passing. And now we go to the second step of the story. And that's how we do it. We do this loop several times until we've implemented the entire feature. And then we check it off and we deliver it to the customer. So which statements do you think are true regarding behavior-driven design and test-driven development? That requirements drive the implementation, that BDD and TDD are used only in Agile, or that they are designed to embrace and deal with change?